All right, 5.2, factoring. Again, whenever you're doing factoring, basically what you're doing a lot of the time is you're doing FOIL backwards. In other words, if I have something that's already in its factored form, and I go ahead and I multiply it out, so again, I'll have my first term. And again, if you multiply a variable term together, you add the exponents. And then I've got my outside and my inner ones. And again, watch your signs as you're doing these. And my last. One of the reasons I like doing FOIL, some of you may have been taught, you can do FOIL with a box on the outside. That's fine too. Some of you do this all mentally. That's good. One of the reasons I like my funny little math humor is that if I do it connecting all the dots like this and I do it right, I get the little smiley face guy there with his nose and his mouth and all that kind of thing. And then I can just combine the terms that are alike in the middle. Again, watching signs, it matters. -4 and 6 is +2. And that would have been my initial trinomial that I had if I was just trying to factor this. It ended up backwards. So this first part should just be a review of what we did last week. No coefficient in front of x squared. We assume it's going to be 1. And like it says here, we're going to have a lot of guessing check, and we kind of just got to tweak things. So if you're a pen type person, you're going to want to have scratch paper available. Otherwise, you're going to be wanting to use a pencil just in case. Because remember, when we're doing these, we're looking to multiply to get the number on the end. And we're looking for two numbers that add to get the value in the middle. So when I go to complete these, I'll always just start with my x, because when I go to FOIL, my first term is going to be x times x, which is x squared. What I put after it is going to be the two numbers that satisfy adding the -12 and multiplying the -28. What may that be? Nice, okay. -14 and +2. So you may have to think outside the box, because most of us, when you think 28, are thinking 7 and 4 probably, or maybe 28 to 1. Sometimes we may forget about those in the middle, where the calculator may come in handy. If I'm not sure, I could just start dividing numbers in. You're like, okay, it's not those. No, divide by 2. Oh, 14, that's right. And that's all I'm doing at this point. As long as I don't see an equals anywhere, find the two numbers that satisfy this, plug them in there with the x's, I'm done. And it's going to be the same way all the way through these. Multiply to 4, add to 5. 4 and 1. 1 and 4, 4 and 1. That is one question that does come up a lot. Does it matter which order my parentheses are in? No. Okay, I could have x plus 4, x plus 1, or what you see here, and they're both one and the same. Nice, okay. X plus 7, x plus 2. And for some of you that are more visual with this, if you need to draw out a diamond so you can see what you're trying to do with the pattern, that's fine. If you need to come off here on the 14 and make yourself a little tree chart on what multiplies to 14, and then find the pair that adds to 9, that's fine. Okay? I'm not going to sit here and say, no, you can't do that. I know teachers that have said, you can't do it this way. Well, I say if you can get to the right answer using the method, you need to use it. Yes, you absolutely can do diamonds. Your final answer needs to look like this. But if you have the diamond, and you're like, okay, I'm more comfortable finding my numbers if I actually write the diamond out, and then say, oh, well, it's 7 and 2 that get me there, and then I plug those numbers in, that's absolutely fine. I have no issue with that at all. Ooh, a little more complicated here. Nice. Man, nothing phases some of you here. Because I know I need a positive and a negative because it's -80. So part of this is like solving a puzzle. There's little pieces that I need to be aware of. And then, right, since I want the 2 to be positive, I'd need a positive 10 and a -8. Positive times negative is negative. Positive 10 and a -8 get me 2. Okay? There will only be one answer for these. It's not like you have multiple options. So if you're like, well, I got this instead, double check, make sure it's covering both things. You may find two numbers that multiply to 80, but they don't necessarily add up to 2. So be careful, be careful, be careful. This is what we were doing on the half sheet before. This next part, now life gets a little more interesting. Now we have a lead coefficient. We have a number in front. I always want to check first. Okay, the golden rule of factoring is always to check and see, is there a greatest common factor I can take out? If there is, I need to do that because that'll usually make it easier. But sometimes I'm not going to get lucky and it's not going to happen. So like for instance here, I'm like, okay, 3, 17, and 10. I don't have a number I can take out of all three of those. You cannot do diamonds on these. Okay? These, we have a couple of other methods that we can try. I'll introduce you to a couple of them. The one I would like you to do the most, if you can, is to say, okay, so how is this going to work? Here's what you have to think. I need my two values at the start to multiply to 3. Well, that's not hard. I only have one option. I'd have 3 and 1. Okay, sometimes you'll have more options than that. But I know that's 3 and 1. So now I got to start playing around with, okay, two numbers need to multiply to 10. So let's think about this for a minute. Multiply to 10. I have 5 and 2, and I have 10 and 1. I need to place these strategically so that when I FOIL it out, I get this negative 17 in the middle. So let me ask one question before we start worrying about numbers. I want two numbers that multiply to a positive, but add to get to a negative. What are my signs going to be on the inside? They both have to be negative, because negative times negative is positive. Okay? That's one piece of the puzzle. Yeah, this is just an X. So now I have to look and say, okay, let's start playing with these numbers. And here's where a pencil comes in handy. Because maybe I'll say, okay, let's try 5 and 2. So if I put 5 and 2 in here, and I go to FOIL, this is negative 6, this is negative 5. Does that up to negative 17? No. Okay? So 5 and 2 that way didn't work. Well, what if I switch them? 3 times negative 5 is negative 15, and negative 2, negative 17. Sweet. Okay, I'm done. So when I say there's a lot of guess and check involved here, there is. Okay? So that's one way that you can do it. Now some of you are like, especially when the numbers get bigger, I don't know if I can manage. Just sit here and keep flipping these, and flipping these, flipping these. This is going to drive me crazy. Okay? I want you to try one more this way, one more my way, and then I have a backup option for you. So number 7, I'm fortunate again. What two numbers multiply to 2? 2 and 1. So I don't have a lot of choices. I'm also fortunate so my 3, I don't have a lot of choices. The only question is, where's the 3 going to go? I'm being told the second. Let's try that out. 2 times 3 is 6, plus 1 is 7. Okay? That one works. If I'd have tried the 3 here first and multiplied it out, FOILed it out, I'd have found that it didn't quite work for me. Here's the next one, is the one where some of you might start to panic. You're like, 8, oh wait a minute, that could be 8 and 1, it could be 4 and 2. Now it could be 9 and 1, 3 and 3. I got too many numbers going on here. This is overload. Okay? Here's an option for you. Let me grab myself a piece of paper. And this may be something, if you're like, this is going to drive me crazy, you may want to jot this down somewhere off to the side. So I don't know if it's going to fit under your example here. Some of you may have heard of this before. I'm one of the first proponents of it here, but I don't know how many teachers actually teach it. When you're factoring, there's another method that you can take that I call slide and divide. It works every time. It doesn't work no matter what type of trinomial you're working with. But it might make things a little bit simpler for those of you that like the diamond. So here's how it works. If this whole thing we've been doing so far is driving you crazy, my first step would be to take this, I slide, multiply, my 8 down to the end. So here's what my new problem is. That 8 literally moves, okay? That's the slide part of things. You're like, oh, so now this is like a diamond. Right. I'm going to take what I have, and I'm going to factor it like that's my actual problem. So I look at this, and I'm like, okay, I need two numbers that multiply to 72, but they're going to add up to 18. Now, this could take a minute, because, I mean, think about this for a minute. 72, I got a lot of choices. I mean, shoot. 2 and 36, 3 and 24, 4 and 18, 6 and 12, 8 and 9. There's a lot of options working here. But yeah, you see the benefit in sometimes writing out what we've got going here? Because now I can visually see, oh, 6 and 12, they add up to 18. So you're like, sweet, this is easy. Do I just leave it that way? No. Because now remember, I said the method was called slide and divide. I haven't done any dividing yet. Well, what do you do to divide? That 8 that I slid before, here comes the divide part. Put it under the number part in each of your sets of parentheses, each of your quantities. If it doesn't go in evenly, because again, 8 doesn't go into 6 evenly, it doesn't go into 12 evenly, can I reduce those fractions? Okay, what do they turn into then? 3/4 and 3/2. You're like, okay. One last part. This is the magic part. Once you've reduced your fraction, and you have to reduce the fraction or this doesn't work, you slide that number back to the front and it becomes your coefficient. Now, some of you are sitting there going, okay, this is too much work to deal with. But if you do not have a quickness and a willingness to play guess and check, guess and check, guess and check, this is your other option. And skipping factoring isn't an option because it shows up and shows up and shows up and shows up. So here again, and I'll show this along with our other ones on one more of these. If you're going to use this, okay, sliding the first step just means we multiply the coefficient to the end. Do a diamond on that corresponding problem that you get finished. And then the divide part comes from your original number in front, your original coefficient. You divide the numbers, reduce the fractions, and if it doesn't become a whole number, slide it back to the front. Because if I FOIL this out, I get this back. Because for some of you, looking at that problem that we were doing here on number 8 to begin with, the whole idea of trying to figure out, is this 8 and 1 or 4 and 2, is this 9 and 1 or 3 and 3, is going to drive some of you crazy. Now, some of you that doesn't bother at all. But it's just one of those things that you have to know what works best for you to get the right answer, not what's fastest, not what's easiest. Okay, what's easiest for you is the way to go. For instance, if we... What's that? Yeah, the slide and divide would be trickier on this one. But some of you are going to look at this last one, 9. Think about the possible combinations there are for 18. Yeah, I mean, you're looking at 1 and 18, 2 and 9, 3 and 6. And not just that, then I've got to look at, well, 14, it could be 1 and 14, it could be 7 and 2. Some of you, if you just start playing with all these combinations and playing and playing and playing, is going to drive you crazy. This one would drive me crazy. Well, not really. I play around enough with these. I know what I'm thinking. But for those of you that were like, okay, let me see that other way one more time, and then we'll play the game this way too, to kind of play guess and check. If I did that on this one, move this up a bit so we can see. You are going to run into some big numbers on these. I'm not even going to lie. It's going to happen. Because if you decide you're going to play slide and divide here, this could kind of get ridiculous. So let's see, 72 and 180 is 252. You're like, oh my gosh, Harty, I don't know what two numbers multiply to 252. What the heck are you doing? This is where your guess part of this will come in. Now, if you're not sure, I'll be honest with you, you're going to have to take that number on the end and start playing with your calculator some. And you're going to have to start playing with the fact that sometimes some numbers you're going to have to test to see if they work or not. And if they do, that's great. And if they don't, then you're going to have to play a little bit more. Like even myself. I'm sitting here right now. I can't do 252 just off the top of my head with a bunch of things. Shoot. All right, so I've got 3 and 84, 4 and 64. And you're like, Harty, those are nowhere near each other. I got to get to 9. Okay, well, let's try some bigger numbers then. It is going to be, like it says up above, a whole lot of guessing and checking with some things. Okay? So finally, thank goodness. Now some of you are like, well, wait a minute, 12 and 21, those don't add up to 9. But remember, remember here, I've got a negative that I'm working with. I know one of these numbers is going to be negative. So, when I see this is a positive 9, if I have a positive 21 and a negative 12, that would be my diamond, okay, of sorts. And again, I'll show you the way you can play with this in a minute if you just want to play the guess and check with other numbers. So I have a negative 12 and a positive 21. Now what? Okay, divide by the 18 that's here. So what are my reduced fractions going to look like? Negative 2/3, 7 over 6. But if it doesn't reduce to a whole number, I have one last step. And that's to swing this back to the front. 3x minus 2, 6x plus 7. Same thing. Like I said, this is the way that'll work every time. And I'm not saying that every single time you're doing this, you're going to get monstrous numbers like this. But I wanted to show you it can happen, and that can show up that way. So I'm not going to tell you that it can't, but at the same time, I'm telling you if I were to take this same paper and start going into guess and check mode, there's a possibility maybe I'm looking at 18 and I'm sitting here off the bat and I'm trying 9 and 2, and then I'm like, oh, 7 and 2, 18, no, and erasing and going back and doing it again. And if you're more comfortable with that, do it. Okay? For some of the smaller ones, that may be the easier way to go rather than going through the entire elaborate process of slide and divide. But if you want a surefire way, the first time, every time, bless you, for it to go correctly, slide and divide might be an option for you that you'd like. That's all I'm going to say on that. And the only time, again, you have to deal with problems like this is when you have a coefficient in front of your x squared term. Okay? Sometimes, though, we've got to factor out a common monomial first, which Harty likes to call the golden rule. That's what you do first on every single problem you see. If there's a number in front of x squared, you always look to see if there's something I can take out before I start. For instance, on number 10. Do those two terms have anything in common? I agree with both of you, whoever said different things there. There's a 4 and there's a t that they both have. They can divide into both. Whatever's left needs to go into parentheses. So 4t times what gets me to 8t squared? 2t. 2 times 4 is 8. T times t is t squared. 4t to negative 4t. Negative 1. Okay? Even if they were the same, I have to have something there to hold the place. When I get my answer, I should be able to distribute here and get the original problem back. And some of you I was telling were having issues with that on the quizzes when I keep talking about take out the common factor and see what's left. And I'm getting strange things. So if you can distribute and get the original problem back, you've done it right. Now some of you might look at 11 and go, ooh, I got to do slide and divide or something. Not necessarily. Not if you're paying attention. They all have what in common? 3. The 3 doesn't disappear. Okay, I don't just divide by 3 and say, ooh, it's gone. No, it's still there. But what I have to do now is, I do divide each of those by 3. But what's left now in the parentheses, my quantity, I need to try and factor it. So can I find two numbers that multiply to -8, okay, and add up to 2? Again, I know some information. Since I see the multiply part's negative, I know one's negative and one's positive. Even if I know that little bit, it helps. And I'm like, well, 4 and 2 seem to be a good plan. And I want the 2 to be positive, so the bigger number has to have a positive sign. There's lots of little things with factoring, whether it's knowing your multiplication tables, paying attention to positives and negatives that can get you. But the nice thing about these, you'll always know if you get the right answer, because I can always FOIL this back out times by 3 and see if I get the original answer back. Ooh, introduction to something new. I like this. 12. Anything in common? The 5. So I'm left with x squared minus 4. Now here's what you need to notice on these. This is going to be the start of us talking a little bit about patterns. If I see two perfect squares here, and there's a minus in the middle because there's no such thing as sum of two squares. All I have to do to factor that, I don't have to use a diamond, I don't have to use slide and divide, nothing fancy. Yeah, what do you square? Whoops, almost did it. Take the square root of each one, right. What's the square root of 4? 2. And since it's minus 4, I get 1 that's plus and 1 that's minus. So when you see a shorty, that's what I like to call them. When you see a shorty that's a difference, we just basically take the square root of each part. So just like it mentions below, if I had a squared minus b squared, square root of a squared is a, square root of b squared is b, and I have a plus minus in the middle. And again, the order of the plus minus doesn't matter. So if I do that same thing here with 10, square root of x squared, x, square root of 9, 3, and again, a plus and a minus. Doesn't matter which order. I'm done. But you're starting to notice, you're like, ooh, so sometimes when they're 3, I might do a diamond, I might do slide and divide, I might do guess and check. When they're 2, I might be able to factor something out. I might be able to factor something out and do this difference of squares thing. My answer of all of the above is yes. So, then, when I get down to the perfect square trinomial. Now, some of you that are creatures of habit, this is a pattern that can quicken things up, but it doesn't have to get you out of your groove. For instance, if you look at 11, some of you are like, oh, I can just do a diamond on this. What multiplies to 36 and adds to 12? 6 and 6. So you could just do this. The pattern that's here, though, is if I have perfect squares on both ends, okay? I have 36, perfect square, I have 6. What's the square root of 36? 6. So I could just pay x, keeping my sign in the middle, plus 6 squared. These are one and the same. So if we had a quiz and somebody wrote x plus 6, and somebody else wrote x plus 6 squared, you're both right. But the big key here is it's just another option for you. It's just another tool in the toolbox as we're trying to work these out. Same thing on the next one. I might notice right away that, oh, I see 16 here. Well, the square root of 16 is 4. So I put my x in 4. But watch the sign in the middle. Minus. So they're both minus. That's minus 4 squared. But again, if some of you look at that like a diamond and you go, what multiplies to 16 and adds to -8? -4 and -4. So it's not one size fits all on this. You've got to sort of play your game with it and see how it works. So when I get down below, okay, with these special factors, Shorty, we don't have to do anything special. We should do these in one step. Square root of 4x squared. 2x, so that's my first term. Square root of 25. 5. Signs in the middle. Positive and negative. I'm done. Because if I'm to FOIL this out, my x terms in the middle cancel. People are like, where did the x's go? They cancel out. Now this one could be a doozy if you went to slide and divide. For instance, if I slid the 9 down, now I'm looking for numbers that multiply to 144 and add to 24. I mean, off the top of my head, it's 12 and 12. But if you notice right away, ooh, perfect square, that can make life a lot easier. Because you're like, okay, what do I square to get 9y squared? Or what do I take for the root? 3y. What do I square to get 16? 4. The sign in the middle is plus, and I'm good. Or I could just write it as one term and call it squared. So that's where you do have to watch here. Now, could I do slide and divide on something like 15? Sure. Okay. Could I just say, well, wait a minute, this isn't even going to be hard to factor, because my only choices are 49 and 1 or 7 and 7. It looks like it's going to be 7 and 7. So you're going to have to find your own group, but the only way to get good at it is to practice it. But here I notice again, oh, perfect squares. 7, 1, and watch the sign in the middle. But your first thing you're going to have to get good at is noticing which type it is to figure out what you need to do. So to start getting you some practice, if you flip this guy over, I bet some of you clamoring for extra credit. Well, here it is. If you flip over and look at the back, which I moved all my papers now, okay, you are only responsible, homework-wise, for the evens. The odds are extra credit. So if some of you are looking for a way to get those couple of extra points back that maybe you lost on the homework check somewhere, okay, here's your opportunity to be able to do that. But they're all mixed up in here. Some of them are just diamonds. Some of them you might, have to play around with the numbers or slide and divide. Some are special cases. Some you got to take a number out in advance. This is one of those type of assignments that will be coming tomorrow. If you've got a question on something, I'm really going to be curious on if you've tried something. If you tried and it doesn't work, leave something there so we have something to look at. Yes. First assignment on the next homework test. Make sure that you are trying something. And if I come by and ask something, you ask me, and I'll say, okay, what example are you working on? Well, it looks like this one, so I'm trying this. Where we can get some dialogue going. Because I'm already starting to see some of you are waiting until the last minute, even this morning, on doing the homework and stuff. You've got to ask questions before, or you've got to try things before. Too much time being wasted. So try these out, see how they're going. Tomorrow we'll talk about some of the evens. Might even get an odd or two, we'll see. And then we're just going to kind of keep plowing along here, slowly but surely.